Hello everyone, welcome back to the channel. Today we will be discussing a question which has been sent to us by Victor. If you remember, the last question was also sent by him. So let's see what the question is. A gigantic pie is split amongst 100 guests. The first guest gets 1% of the pie, second guest gets 2% of the pie, of remaining pie actually. This is important. Third guest gets 3% of the remaining pie, and so on, until the last guest gets 100% of the remaining pie. So if it's xth guest, he or she gets X percentage of the remaining pie. Okay, excuse my handwriting here. Which guest gets the largest piece of pie? The challenge is to solve without using calculators or computers. Challenge accepted. If you would like to give this problem a try, then pause the video, else continue watching for the solution. So first, thanks to Victor for this question. In these type of questions, we always need to form equations in terms of the ith or xth variable. Let's say if Pn denotes the share that nth person got. By share, I mean in terms of fraction. Okay, so we will consider the whole pie as one unit. Okay, so he or she will get n% of the remaining pie, right? What is the pie remaining here? It is 1 minus sigma of I equals to n 1 to n minus 1 of pi, right? How is this? Let's see example. So for P1, it's very easy. It's 1% of 1, right? I've taken a unit pi just to denote it in terms of fraction. P2 is 2%, 0.02 into of the remaining pi. Whatever 1 minus whatever is eaten by P1, right? So this is 0.02 into 0.0, sorry, 0.99. This is 0.0198. Similarly, for P3, it is 3% of 1 minus P1 minus P2, right? So we can similarly form this equation. So what is P of n plus 1? It is equal to n plus 1 by 100 into 1 minus sigma of I equals to 1 to n pi, right? Now we can rewrite this equation. Let's take it as 1 and 2. This can be written as 100 times Pn upon n. I just took this fraction to the other side, equals to 1 minus sigma of I equals to 1 to n minus 1 pi. Okay, let's say this is equation number 3. Now let's solve this equation. Let's try breaking it. P of n plus 1 equals to n plus 1 upon 100. 1 minus, this sigma can be broken into sigma of I equals to 1 to n minus 1 pi, and this, since it was n, we get another minus pn directly, right? It was a sigma, I just took out the last term, right? So this is equal to n plus 1 upon 100. So what we can do here is we can substitute from 3. We know the value of these, right? Here. So this is 100 pn upon n minus pn, right? So let's go some further down. So this implies, so let's take this 100 on the pn side, or let's just keep it here only. P of n plus 1 equals to n plus 1 upon 100. This would be 100 minus n upon n, right, into pn. Okay. Now let's write this equation in terms of n. Just substitute this another. n plus 1 by n. Okay, actually n by n minus 1. That would be better. So this would be p of n minus 1 plus 1. This is equals to n minus 1 plus 1 upon 100. This would be 100 of minus n plus 1 for n minus 1 into Pn. Okay, so this n minus 1 here. Actually, my bad. So this is Pa of n equals to n upon 100 into 101 minus n upon n minus 1 to P of n minus 1. So we are taking this as a fraction, right? A value, a fraction, something out of 1, right? Out of some n out of 100, right? So since P of n minus 1 or any Pi is represented as a percentage or a some part out of 1, which is less than 1. So this value would always be less than 1, right? We can see above here, right? P of 1, P of 2, P of 3 would also be less than 1. Okay. So this would always be less than 1. So it's just a part of 1, right? So it's some fraction or percentage of 1. So now any number which is less than 1, right? So any two numbers which are less than 1, when you multiply them, you will get a number less than each of them. Why so? Let's consider two numbers A and B. Okay. So if A is less than 1, it can be written as some A dash times 100, right? Where A dash is less than 100, right? Since whole number has to be less than 1. So it is just a percentage of B, right? So it would be less than B. And similarly, we can prove it otherwise. So, so P of n can only be greater than P of n minus 1 if this is greater than equal to 1, then in case of 1 equal to equal, otherwise it would be greater, right? If it is less than 1, then we know that this is less than 1, and if this is less than 1, then the value would be again smaller, so it would decrease. So we need to find all those cases where this is greater than 1. Then multiplying with p of n minus 1 would increase it. So let's solve for that. N by 100 into 101 minus n upon n minus 1 is greater than equal to 1. This is 101n minus n square greater than equals to 100n minus 100. This implies, let's take everything on the RHS side. Actually, just yeah. So this would be, or this would be 0 less than, this would be n square minus n minus 100, right? So this implies n square minus n minus 100 less than 0, equal to 0. So we need to find all those cases. It's a quadratic equation. We can use the formula minus b plus minus root over b square minus 4ac by 2a, right? Where b is minus 1, a is 1, and c is minus 100. Okay. This is equals to 1 plus minus root over b square is minus 1 square minus 4, a is 1, c is minus 100, right? Upon 2a, a is 1. This is equal to 1 plus minus root over 1 plus 400 upon 2. This is equals to 1 plus minus root of 401 and 2. This is equals to 1 plus minus some 20 point some x, right, upon 2. So 20 square is 400. So this would be slightly greater than 20, right? So if we draw this quadratic equation, we would get one root here somewhere, negative 1 minus 20 point something, and another here, right? So what would that be? Let's focus on this root. Let's call it some z. So z equals to 1 plus 20.xx upon 2 equals to 21.xx upon 2 is to 10 point some y, right? Something, I don't know whatever it is, but something, right? So it's just greater than 10, right? So for all these values from 0 to 10, we can see that this equation which we got above, this equation is less than 0. So yeah, so a was greater than 0. So the quadratic function is so it's a concave, right? Concave upwards, right? So 10 is here. So till all this point n satisfies our condition, so it would be increasing. But after 10th point at 11 years something, it will start decreasing again. So where will we get our maxima? At 10. Since p of 1 would also increase it, p of 2 would also increase because this all would be greater than 1 as we have solved the equation. So till 10, this would happen. So the largest value we will get at 10. Okay. You can also plot this equation. Sorry, this is, let me check. Yeah, this was the equation on any online graph calculator. Okay. Also, there is a, if you like the solution, then don't forget to subscribe the channel. Also, there is a C++ program written which has this link in the first pinned comment, also in the description. So you can check that out to verify for yourself that 10th is actually the answer. Thank you.